Hello. In this presentation, I'm going to explain to you how to create the ANOVA table for a 4x2 factorial design. It is related to my previous presentation on the factorial design. In this case, I have two factors. One is the housing, other is the weight loss. Housing has four factors: cage, the free, the burn, and the organic. And the weight loss has the medium and the large. And here's my data set. This is the exact data set that I have shown you in my previous presentation. Here I'm going to show you the detailed calculations in the Excel. Okay, so first of all, we need to find out the overall mean of this data set. And the way I did, I add all of those numbers and divide by 28. So that gives me the overall mean of the data set. Next, I want to calculate the main effect. And for the main effect, you can see main effect for the housing and the size. For the housing, I got the average of the housing. You can see this is the average of the cage. Next one is the average of the free. Next one is the average of the burn. And the following one is the average of the organic. Okay, so these are the average. And these are the number of observations that I use to calculate this average. For example, here I have used 10 observations and so on. And the rest of them are 6. Now to calculate the sum of square for the main effect of housing, I use this formula, Ni times x minus mu square, hat square. And mu is this. Actually, it's x bar. I just put on mu here. So you can see this is the formula. G18, which is this, times F18 minus of this. You need to have a parenthesis and then to the power 2. So by doing all of those exactly by using the same formula for this appropriate cell reference, but this one is going to be the same. This $12 means this is not going to change. This mean is going to be same for all of them. Now I add these numbers. This gives me the main effect, sum of square of main effect for the housing. Now again, housing has 4 levels, 1, 2, 3, 4. So the housing degrees of freedom is 3. 4 minus 1 is 3. And sum of square is 9904.79. Okay, here it is, 9904.79. Degrees of freedom is 3. Okay, next, for the size, I can again get the large and the medium. So for the large, I take the average of all the large, and for the medium, I take all the medium, the average of all the mediums. And there are 14, so I divide by 14. So sample size, in this case, Ni, the number of observations based on this average is calculated is 14, and I use exactly the same formula to calculate this formula to calculate the mean effect, sum of square of the mean effect for the size, weight loss. And the formula is this. And I use again the same mean for the subtraction. Now when I add those two numbers, I get the sum square of the main effect for the weight loss. So the sum square of the main effect is 660.5714, and there are 2 levels, so the degrees of freedom is 2 minus 1, which is 1. So the degrees of freedom 1, sum square is 660.5714. 660.5714, weight loss is 1. Okay, now we need to get the interaction effect. For the interaction effect, my marginal table is going to be this. Now in this case, I'm going to calculate the combination of, for example, the cage and the low. So cage and the low is right here. I take the average of these numbers, and then cage and the medium will be the next one. Cage and the medium will be the next one. In this way, I calculate all the averages. You can see that I did not use the average formula, but I used the sum divided by 5, which is basically the same. And so on. For this one is B and the large, and the next one is B and the burn and the medium. Burn and the medium. So I calculate those averages. And then these are the number of observations that I have used to calculate these averages. And then I use this formula, exactly the same formula that I have used here to calculate the sum of squares. You can see the sum of squares, again, I'm using the same mean. That gives me So I get the sum of squares. I add all of those sum of squares. These are the marginal total. Here, this one. And that one is also the marginal total. And I just add these to marginal total. But you can add this sum also to avoid, if you want to avoid one more stage. This is the sum square of the total effect, main and interaction included. So to get the interaction effect, from these, I subtract these two main effect. I get this is the interaction effect. You can see the formula. So this, which is S23 minus H23 minus H28. So that gives me the interaction effect 281.8286. Interaction effect 281, 82, 86, 82, 82, 829. 829 right here. And the degrees of freedom will be this multiplied by that. That gives you the interaction degrees of freedom. Okay, now we are going to calculate the error sum of square. To calculate the error sum of square, we need to calculate the total sum of squares. And the way we are going to do it, we are going to calculate the individual component of the sum of squares, which is, you can see, this number. For each of those numbers, I need to calculate this number minus this number square. And you need to have a parenthesis. So parenthesis, the first observation is minus M12, which is the overall mean. So x minus x bar, basically, the formula. And then calculate all of those numbers, and then take the sum of these numbers. That will give you the total sum of squares. Now from the total sum of squares, if you subtract all the main effect and the interaction effect, that will give you the error. You can see the total sum of square is this minus that and that. That will give us the error sum of squares. So it is 3987. So when I go there, it is 86 because I have the size is right here, 3986.67, and then if you go there, 3986.67, and the error degrees of freedom will be 27 minus this minus this minus that. In the same way, error sum of square is total sum of square minus this minus this minus that gives me the total sum of square. Now the mean sum of square is sum of square divided by the degrees of freedom. You can see here. And this formula is the same for each of those. That's how you calculate the mean sum of squares for all of those. And then you have F. F will be the corresponding mean sum of square divided by the error mean sum of squares. You can see here, and here, and here. And then you get the p-values. P-values are critical probabilities corresponding to the observed value. So I used F DIST formula and corresponding degrees of freedom for the numerator, and the denominator. Denominator is the error, so that's what it is. So now you have all the p-values, and these are the critical values. You can use the Excel formula right here. You can use the Excel formula to calculate the critical values, and that formula is right here. That formula is FINV 0.05 numerator degrees of freedom, comma denominator degrees of freedom. Okay, so those will give you the critical values. Now you can see in this case, observed value is larger than the critical value, so you reject the null hypothesis. In this case, you do not. In this case, also you do not, for the same reason. Okay, so now you have all the analysis, and you can create the Excel page by using the step that I have shown you. I will suggest that you use the same numbers, start with this, and then try to go through the steps to calculate all of those numbers. Okay? Thank you. Bye.